For more than a century, air attacks have posed a major threat to ground forces and population centers, as well as to vital military and civilian infrastructure. This is unlikely to change in the foreseeable future. Today's air threats range from fixed-wing combat aircraft and attack helicopters to cruise missiles, unmanned aerial systems, precision-guided munitions, and even ground-fired rockets, artillery, and mortars. These air threats may persist by day and by night, irrespective of bad weather, terrain, and poor visibility, and under severe ECM conditions. The main trends to be expected in the near future are an increasing degree of attack accuracy, saturation, and coordination, a full exploitation of the terrain masking opportunities, an intensive and extensive use of electronic warfare techniques, and night as well as all-weather operations, all resulting in reduced target visibility and operated in an integrated network environment. Only reliable, high-performance air defense systems with advanced, automated command and control systems provide the necessary means to counter and defeat the symmetric and emerging asymmetric threats. The Skynex baseline configuration in existence today is the optimal base to grow its capabilities in the near future. The baseline system consists of a sensor package, a shooter package, and a command and control package. From the remote tactical layer control node that houses the interface to Skymaster, the medium-range radar Oerlikon XTAR 3D and up to 4 Oerlikon revolver guns Mark III are controlled remotely from a safe distance. The XTAR 3D is a 3-dimensional target acquisition radar and provides the local air picture up to an instrumented range of 50 kilometers. Besides classification and identification of air targets, the XTAR 3D delivers accurate 3D target tracking data to the control node, from where the target data are processed based on automatic threat evaluation analysis and then sent to the effectors. Depending on mission requirements, up to 4 revolver guns Mark III form the shooter grid. The unmanned revolver gun Mark III combines exceptional precision with high firepower, firing up to 1,000 rounds per minute. With its own sensor unit consisting of a tracking radar, a TV, and an IR camera, as well as laser rangefinders, the gun can take over any in-range air targets assigned by Skymaster and autonomously track and engage such targets. Using the programmable 35mm ahead ammunition, the gun is able to hit even the smallest targets. With this setup, we are today able to engage aircraft, cruise missiles, small to large tactical drones, air-to-ground missiles, as well as mortars and artillery rockets up to distances of 4 kilometers. This is the current capability that is fielded under the name of Oerlikon Skynex at the present point in time. Looking into the near future, Rheinmetall will augment the current Skynex capability in order to deal with a new type of threat. Cheap and small weaponized commercial off-the-shelf drones are easily and in large quantities available these days and pose significant threat to armed forces and also to civil installations. Using electronic warfare measures, such threats can be successfully countered at relatively low cost. For this purpose, Rheinmetall has a close cooperation with Elettronica from Italy. Their effector suite in the electronic warfare domain comprises communication and GPS jammers, as well as radar band jammers. Passive emitter detectors, laser warning receivers round up their portfolio. These systems can easily be integrated into the already existing Skynex configuration at low cost, as no amendments to the sensors or the control node are necessary. Obviously, electronic warfare effectors do not disperse any expensive ammunition, and so an engagement is very cost-effective. This technology is already available and can be integrated in a short period of time. With SkyMaster, Skynex has all necessary interfaces to be integrated into an overarching command and control system, such as a battalion layer control node or a higher echelon air defense command center. These command centers operate with a recognized air picture from various sources. With its modern sensors, Skynex therefore has the potential to contribute significantly to this recognized air picture by transmitting its own local air picture via a tactical data link to the command center. In return, Skynex can receive target data from other air defense systems or command authority and improve its surveillance capabilities without adding additional sensors. The result is a truly layered air defense architecture, where all air defense means are fully integrated, achieving the highest possible degree of efficiency. Besides constant improvements on their gun systems, Rheinmetall has also been working on new weapon technologies for more than a decade. An ambitious but also very promising project is the high-energy laser system. Its scalable lethality, the low cost per engagement, and the extended engagement range make it the ideal weapon against unmanned aerial systems, in particular drones and other low, slow, and small targets that come in masses. Integrated into the Skynex air defense system, the high-energy laser system certainly adds a first level of saturation resistance that is well required looking at the future threat scenarios. With the current status of the development, Rheinmetall expects its high-energy laser system to be ready and fully operational by 2025. To round up the shooter grid, Rheinmetall is currently developing a new type of very short-range air defense missile. The counter-PGM and counter-RAM missile is specifically designed to counter hard-case targets, such as precision-guided munitions and large artillery shells. With its extended range of up to 6 kilometers against such targets and its multi-launch capability, Skynex will experience a significant performance increase against saturation attacks and enhance its target spectrum. One missile launcher containing up to 60 ready-to-fire missiles can launch up to 5 missiles per second on individually assigned targets. Furthermore, thanks to engagement ranges of up to 10 kilometers against soft-case targets, the new missile significantly increases the combat radius of Skynex and truly contributes to the approach of a layered air defense system. The counter-PGM and counter-RAM missile is planned to be fully operational in 2026. In order to improve the sensor grid of Skynex with regards to saturation and in the future swarm attacks, and to fully exploit the capabilities of the counter-PGM and counter-RAM missile, Rheinmetall has also launched the development of a new type of sensor. The Skynex Advanced Multi-Sensor Unit is the next generation of short-range air defense sensor unit for target search, acquisition, and tracking. The modular architecture allows a combination of various functional modules and sensor technologies, such as active electronically scanned array. The AESA radar suite is complemented with an electro-optical sensor package holding an infrared and a TV camera, as well as laser rangefinders. The AESA radar technology provides full azimuth search coverage and guarantees simultaneous detection of different target types. The advanced multi-sensor unit can seamlessly be integrated into the Skynex system and is remotely controlled from the control node. It will be fully operational and available contemporaneously with the new effectors. Grow your air defense capabilities along with your challenges. With Skynex, you're ready for today's and tomorrow's technologies. Oerlikon Skynex, the ideal air defense network for modern force protection.